So I'm a big fan of the stovetop siphon brewer. And a lot of these fancy coffee shops like Blue Bottle that serve siphon brewed coffee, you'll see that they go through this process where they first boil the water, and then when the water's close to hot they put the top on, and then they wait for the water to come up, and then they kind of measure the temperature of the water at the top, get it to the right temperature, pour their coffee in, stir a little bit, and then time it. For stovetop use, that seems pretty intensive. I was wondering, is there a way that I can figure out to get the water in at a consistent brew temperature without having to go through all this madness of like whipping out the temperature probe every single time in order to measure the temperature, the brewing temperature? Because the first thing I wanted to see was how well we can regulate the temperature by pressure alone. And yeah, I had an inkling this probably isn't going to work, right? The PV equals nRT and all that. But we can see that if I just plop the top on and I turn the heat on and a bunch of warm water, the water will come up even though it's not even remotely close to boiling. Right? We can see here the water here is at a mere 156, right? And so clearly I cannot depend on the action of the water coming up as a measure of, yes, I have proper brew temperature, right? You can see the water does get hotter now because there's steam bubbling through this, but there's no possible way without the thermometer that I could ever figure out what the right brew temperature is, based on time alone, by just putting a bunch of unknown temperature water on the stove and then letting it come up. So that's obviously not going to work. You'll notice that the water was also not hot enough, so it didn't generate that much reverse suction to pull it down. So I'm going to pull it out so that I can gravity feed the water back down to the bottom, and we can try something different. So the next thing I'm going to try is this thing where we bring the water up to boiling first, or close to boiling, and then turn down the temperature. By being able to see the bubbles in the bottom, I should be able to say, well, the water at the bottom of the glass is consistent. It'll always be, close to boiling when I see the bubbles. And then, does water at that temperature come up at the right brew temperature, or does the process of coming up cause the water to get too hot because we're too close to boiling, or is it perhaps too cold going through the process? So I've got the water kind of fairly high here. We can see, okay, there's some bubbles forming, and it's getting close to boiling. The top is moving. I figure that, okay, at this level it's slightly under boiling, but I could consistently notice that, okay, we've reached this temperature for the water without having to use a thermometer. Bubbles are starting to form. I'm going to pop the top on and then turn the heat down so it doesn't come up too madly. So you see the water that comes up at this temperature actually is fairly decent. So okay, the water was a bit high, it came up, but the water comes up at just around 200, and then since the temperature's on low, it kind of stabilizes out, in this case at about 202, maybe because I had the water on really high on before. But this is kind of a decent brew temperature. So that makes me think maybe it's possible for me to get a decent brew by dumping the coffee in and just letting the water rise up over it, kind of shorten the steps for a daily brew. And then, of course, there is some water bubbling through this even though it's on low. So if I'm going to do a simulated brew, I'm going to count down 60 seconds. So about 60 seconds on the clock. And I want to watch then on the thermometer, where does the water go? How does the temperature go during the 60 seconds? We see that the temperature actually, at low on this stove, and of course other stoves may vary, actually stays right around optimum. The temperature came down some after I turned down the heat, and this is what we would expect in a normal brew, maybe a non-siphon brew. There's no heat being added. It would cool down, and this is also cooling down. It's at 170 and dropping, 160, 167.5. We've got, for a 60-second brew time, I've got 15 seconds left on the clock. And the water temperature, the big thing is the water temperature is not going up. So I'd actually expect that if there were actually cool grounds in there, that it would start at a lower temperature and drop down. And that was 60 seconds. So in the simulated brew, we went, if I had just put the coffee in while the chamber was empty, boiled until I saw the bottom started bubbling and let that come up, wait 60 seconds and then come down on low during the brew temperature, looks like I would have a brew that starts at around 201, 202 max, probably less if this weren't a simulation, and then coming down to about 195. That gives me some hope that I can create a kind of a simple, self-timed stovetop siphon brew process.